Okay, here we'll start the third section. Okay, and the second section of new class. Here we'll continue to learn how to use the one-way analysis of covariance. One-way analysis of covariance for data analysis. Okay. Here, I give you an example. Please open the data, pick and feed. Okay, and we will use this data to analyze. In this file, we have one variable is the feed type. Another variable is the weight. Weight before feed and weight after feed. Okay, everyone, did you still remember the what we have learned? The tea, drink tea to lose weight. Did you still remember? We have different types of tea. Yeah, no, we have one type of tea, and before we drink the tea, we weight the paper and record the weight. That's the weight before tea. And after drink tea for 3 months, we also weight the same paper and we record the weight. And that's the weight after tea. Okay, I think you still remember that. Here, we will use the pigs as the respondents. By now, here we use 3 different types of feed. Okay, so yes, all the pigs will divide it into 3 groups. One group, we will feed the type 1, and the second group, we will use the second feed, and then the third group of pigs, yes, they will eat the type 3 feed. Okay, so and we will record the weight before feed and the weight after feed. Okay, so yes, we want to analyze if the feed type impact has the significant impact on the weight after feed. Okay. This time we think besides the feed type, maybe the weight before feed will have impact on weight after feed, right? So we will analyze if the weight before feed can be used as covariance. Okay, can be used as covariance. Okay, so that's the first we need to test. Yes, that's the one-way analysis of covariance, right? So firstly, we think about the weight before feeding can be used as covariance. Okay, here we will draw the scatter diagram of body weight and weight gain before pig feeding. Okay. See here? Yes, here is the types of feed. The weight before feed, the the weight before feeding, but yes. The weight before feeding, look here, the pigs is very light, for example 15, but the weight after feeding, the pig will be 85. So the type of feed is very, very helpful for the pigs to gain weight, right? Okay, firstly, let's look at if the weight before feed can be used as a covariance. Yeah, select graphs, legacy dialogues, legacy dialogues. Here, scatter. Okay, simple scatter. Okay, y-axis, weight after feeding. X-axis, weight before feeding. And then the feed type will be the set marks by the feed type. Okay, yeah. Then click OK. Now, we can see the weight after feeding and the weight before feeding, right? The x-axis is weight before feeding. The y-axis is weight after feeding. Yeah, because it's hard to see the marks, so we can change the color of the marks. I double click. Okay, and the feed type, since the type 3, the color is hard to, it cannot, for example, I would like to change it into a purple. Okay, also here, the marker, the type of the marker, I would like it to be a triangle here. And the border width, yes, to be thicker. Okay, so apply, close. Then here shows the feed type 3, the weight before feeding and the weight after feeding. Okay, then type 2, yes, I would like it to be the width wider. Okay, the type, just keep it. And then the type 1 here. Okay, maybe the type can be some airs, for example, coarse, border width. Okay, purple, blue, and here the blue one. Okay, so I think the size can be larger. So 8, size 8 will be better. Okay, great. Okay, now I have this plot. Okay. Now, let's look at the plot here. Yeah. Can you see that the weight before feeding, the weight after feeding, for each feed type. Yes, let's look at the purple, the triangle. Yeah, from here you can see that the weight before feeding, the weight after feeding, they have a linear trend, right? Yeah, it has a linear trend. And next, the type 1, it also has a linear trend. The type 2 has a linear trend, right? Okay, so firstly, from the plot, you can say that for different feed type, the weight after feeding, the weight before feeding, they have the linear trend. Okay. Second, when we look at the linear, also we can see that the slope of the linear of different feed type, they are very similar. Okay, can you see the slope of the linear, the slope of this linear, the slope of this linear, they are very close. Okay, so if these two requirements meet, then we can say that weight before feeding can be a covariate, can be used as a covariate. Okay. So we answered this first question. Yes, after we draw the scatter diagram of body weight and the weight after pig feeding, the weight before feeding can be used as covariates. Okay. Okay. So our answer is the weight before feeding can be used as covariance. Yes, that's our result. That's our conclusion. Okay. Why? Why? Because the weight before feeding and the weight after feeding, yes, all of these markers in different feed types, they all has the linear trend. Linear trend, linear trend, linear trend. Okay, and then second, the slope of the linear trend is same or is similar. So that means the weight before feeding can be used as a covariate. Okay. After we answer the first question, next we will use the covariance analysis to analyze the effects of feed type on weight after feeding by excluding the influence of pre-feeding weight. Pre-feeding weight. Okay, that's the weight before feeding. We also call it a pre-feeding weight. Okay, so that means we will excluding the influence of pre-feeding weight Then we will analyze if the feed type has the significant effect on weight after feeding. Okay, on weight after feeding. Okay, so here, let's look at the analyze here. Analyze here. Yes, we will use general linear model here. Univariate. Okay. Here, dependent variable is weight after feeding. Okay. Fixed factor. Here, fixed factor is the feed type, because feed type is a fixed, and weight before feeding is the covariate, right? Here's the covariate. Okay, so weight after feeding, dependent variable, feed type, fixed factor, weight before feeding, covariate. Okay, next, please select the model here, because now, if it's a covariate analysis, then you need to establish a custom model. So select the custom model here. The feed type, the weight before feeding. Okay, please input the feed type, the weight before feeding, and then continue. Okay, let's look at the result. Now, look at here. Feed type, type 1, type 2, type 3. Each type has 8 cases. Each type has 8 cases. So totally we have 24 picks. Okay. Each group has 8 picks. Then here's the result. Look here. Yeah. If here is the weight before feeding, right? Weight before feeding. The weight before feeding, the F value is 88.813. The corresponding significance is less than 0.001. If it's less than 0.001, it's absolutely less than 0.05, right? So since it's less than 0.01, so that we can say that the weight before feeding has very significant impact on weight after feeding. Okay, let's look at this result. This shows by excluding the influence of weight before feeding, the effects, the feed type has very significant impact on weight after feeding, because the F value is 88.81. No, sorry. The F value is 31.7071, and the corresponding significance is less than 0.01. We can conclude that excluding the influence of weight before feeding, the feed type has very significant impact on weight after feeding. Okay, so here we answered the second question. Okay. The F value is 3, 1. Okay. The corresponding significance the 1. Hence, by excluding the influence of pre-feeding weight, the feed type has very significant impact on weight after feeding. Okay? Yeah. Here we answered the second question. Third, please compare since the feed type has very significant impact on weight after feeding. Then next is please compare the effects of 3 kinds of feed on promoting the pig weight. The pig weight, okay? Compare the effects of 3 kinds of feed on promoting the pig weight. Which feed is the best? Which is the worst? We want to draw conclusion. Which is the best feed type? Which is the worst feed type that we will not use? Which one we will prefer to use? Okay, so we will compare. Okay, here, yes, you can use the contrast. Simple. So here, we will continue. Contrast here, right? Contrast. Yes, you can use symbol. Symbol, firstly, yes, the default reference category is lost. Yes, that we can keep it. Change. Simple. Okay, continue. Okay, let's look at here. Here is the contrast. Yeah, Level 1 vs level 3, level 2 vs level 3. Look here. But here we don't know how about level 1 vs level 2, right? So we would use reference category level 1. So we will continue. Here, contrasts. Yes, we will change the reference category from last to first. Okay, change. So you can see first, it shows first. Continue. Okay. Okay. Copy the level 1 to level 2 to here. Okay. Okay, see level 1, level 2. Yeah, here is level 2 to level 1, right? But if it's level 1 to level 2, then it's 4.542. Okay, and the significance is 0.042, which means level 2 is significantly better than level 1, because level 2 minus level 1 is 4.4542, and the corresponding significance is 0.042. Okay, so 2 is better than 1. When 2 minus level 3, the mean difference is 17.336, and the significance is less than 0.001, which means level 2 is significant better than level 3. The mean difference is 17, right? So from here, level 2 is the best feed type. It's better than 1, it's better than 3. So level 2 is the best, right? How about level 1 and level 3? Do they have the significant difference? Let's look at level 1 and level 3. Level 1 minus level 3, the mean difference is 12.793, and the corresponding significance is 0.001, which is less than 0.01. Okay, so that means level 1 has very significant difference with level 3. It's better than level 3. Okay, so through this comparison, which feed type is the best? Which feed type is the second? And which type is the worst? Okay. Which? Would you please tell me the answer after comparison? Yeah, from here, level 1 minus level 3, the mean difference is 12.793, and the significance is less than 0.01, which means level 1 is significant better than level 3. Level 2, level 3, also level 2 is better than level 3. Level 1 better than level 3, level 2 better than level 3, so level 3 is the worst. Okay, and then when level 2 vs level 1, level 2 minus level 3, level 1, the mean difference is 4.542. Okay, and the significance is less than 0.05. So that means level 2 is better than level 1. So the type 2 is the best. The type 3 is the worst. Okay, that's the results. Yes, yes, Fraser, yes, you're right. Great, great. Okay, that's the results and the conclusion. Okay, okay. Okay, next, yes, let's look at today's after class exercise. Okay, please complete practice 4. Okay, practice 4. Okay, that's the assignment. Practice 4. And practice 5. Okay, here's your after class assignment. Please complete and send me your assignments. Okay? Yeah, that's all for today's class.